Hi everyone, in this lecture I am going to describe the instrumentation of UV visible spectroscopy. UV visible spectroscopy measures how molecules absorb light. It is essential for quantitative analysis, kinetic studies and purity assessment. The principle involved in UV visible spectroscopy is absorption. The molecules that are present in our sample will absorb the electromagnetic radiation, that is UV or visible radiations, and they will electrons present in the molecules will move from ground state to excited state, and the amount of energy that is necessary for the molecule to move from ground state to excited state is measured. That is the principle behind UV visible spectrophotometer. The light absorption, that is molecule absorb photons in 190 to 1100 nanometer range. That is going to be our light radiation, wavelength of our light radiation. And electronic transitions, absorption causes the electrons to move to a higher energy states, that is pi to pi star, n to n pi star. Beer-Lambert's law, absorbance A is equal to molar absorptivity into path length into concentration, and quantitative insight, higher absorbance indicates greater concentration or stronger light absorption. The light sources that were frequently used in UV visible spectroscopy is deuterium lamp. They emit UV light 190 to 400 nanometer with low noise, features precise calibration. And tungsten halogen lamp provide visible or near infrared light 350 to 1100 nanometer, operating at approximately 3000 Kelvin. Then xenon flash lamp, pulsed broad spectrum 190 to 1100 nanometer with a long lifetime and ideal for diode array systems. Then wavelength selector. Wavelength selectors are otherwise called as monochromators. The main function of monochromators are to convert the polychromatic lights into a monochromatic ones. They isolate the wavelength, filters a narrow band of light from the broad source. Key components include entrance slit, diffraction grating and exit slit. The first component is entrance slit, where the light radiation from the light source will enter our diffraction grating, and the diffraction grating is a dispersive element that can be either prism or a grating. They convert all the polychromatic lights into monochromatic ones. And then the exit slit, this exit slit is mainly necessary for choosing what we need to pass through our monochromator. And then high resolution, typical resolution from 0.1 to 2 nanometer for a detailed analysis. And then reduced stray light, double monochromators minimize the stray light for enhanced accuracy. Stray light means the light that is not necessary for analysis, that is the light that is beyond the range we have chosen are called stray light. So by using this monochromators we can limit the presence of stray lights also. Then sample compartments and cuvettes. Cuvette material can be made from the sample compartment consists of cuvette materials. The cuvette can be made up of quartz for UV or visible, and glass for visible or near infrared, and plastic for visible or common options. The path lengths are from standard 1 cm path length with micro volume and flow cells available. The temperature control, Peltier elements ensure precise temperature regulation for kinetics. Then detector. So detectors are something that converts all the light energy into a electrical signal. The signal conversion, that converts the light intensity into an electrical signal. And then photomultiplier tube is one of the detector, which is the most sensitive one and is used in many instruments including UV visible spectrophotometer. The photomultiplier tube consists of a cathode and a series of diodes. They work by the principle of multiplication of photoelectrons by secondary emission of electrons. It can detect even weak signals. It can multiply the signals to the extent of 10 to the power of 6. And then photodiode. Photodiodes are one of the detectors, the solid state and robust and providing faster response in array detectors. And diode array detectors measures all wavelengths simultaneously, enabling the rapid full spectrum acquisition. Then signal processing. and data output. Now we have got converted all the light energy into an electrical signal. The next step is signal processing or data output, that is a readout device. Analog to digital conversion, analog detector signals are transferred into digital data. Computer control, software manages instrument settings and data acquisition. And then advanced analysis features include a baseline correction and quantitative curve fitting. Then comprehensive output provides spectra, kinetic plots and detailed concentration reports. Applications and conclusion. The UV visible spectrophotometer is used for quantitative analysis, that is precise determination of substance concentrations, and qualitative analysis, identification of compounds and functional groups. And then broad versatility, crucial tool in diverse scientific and industrial fields. And then kinetic studies, monitoring dynamic reactions rates over time.